I want you to look on your periodic table, and there's this thing called atomic weight. Okay? Now, administrators, they always like to come in at different times, and one of the things that they test me if I'm doing a good job on, they will ask you a question like, and they'll come up to you and they'll go, what are you guys working on? And then what would you say when it comes to finding that weight up there? Any of you? Yeah. So then they'd say, well, how do you find atomic weight? And you would tell them what? Okay, you can look on the periodic table to find it. And then they say, well, they'll ask you, have you been practicing finding that another way? And you would say, yes. And you would say, how would you do that? What do you need to know to find that weight up there?
The different isotopes that are in
The different isotopes in their weight. So make sure they come to you. Okay? Not mad if they do. So the different isotopes. And what else? What do you have to know about those isotopes? Their weights, individual weights, and their abundance. Then you can multiply them and get that weight. So those, do you guys ever wonder, what do they use this weight for? This atomic weight for? Now you guys know what that number is for, right? The atomic number, that's the number of what? Protons, right? Okay? And you know that this weight is probably about what the weight of or the mass number is going to be. You know, give or take a few numbers. But that number is the average. How many copper isotopes have the weight of 63.546? How many isotopes do you think of copper? There's only two isotopes of copper. It's copper 63 and copper 65. So how many of those atoms have that weight in AMU? 0. Right? Because that copper 63 is going to be around 63 AMU, and copper 65 is going to be around 65. That is 63.546. Okay? That's just like the beans. How many is going to have a weight of 0.291 grams? 0. All right? Not going to be any. But that is an average. And we have to use the average in which to come up with the total amount of atoms or grams in that when we do that. So this number, the number on your periodic table, that decimal number, now you guys get to know why it's used. You'll have them memorized too. Okay? You'll have them memorized. So, like nitrogen be 14.01, carbon's 12.01, hydrogen's 1.01. Okay? Helium's 4, lithium's 6.941, and sodium's 22.98. And so a lot of those you'll have memorized down. You don't have to look at the periodic table. Okay? You'll be impressive. You'll be impressing your friends that aren't in chemistry, and you'll say, oh, I know what that one is. All right? And maybe not impressing them. Okay? And so what do you use that for? You use that to count atoms. All right? So let me give you an example of what we're doing, counting atoms. So if you look at the periodic table, let's say I give you, before we do that, they have what's called a mole. All right? So what is moles? So if I have a mole here, what's the definition of that? Huh? It's, it's based upon a weight, but a mole is a count. And what do they compare it to? The mole, it says a mole is the amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. So 1 mole of atoms in carbon-12 is that number. Okay, so 1 mole, we'll say 1 mole is equal to what we call Avogadro's number. If you look at the second set of paragraphs on 83, what is Avogadro's number? Okay, so that is equal to Avogadro's number. And that number is 6.022 times 10 to the 23rd atoms. So if I have if I have 1 mole of atoms, that's that number of atoms. So let me give you an example that's easy to understand. If I have 1 dozen eggs, how many eggs do I have? 12 eggs. All right. So guess what? What's the difference in these two? That big number. And some people get psyched out with that big number. If I give you like dozen, if I say, okay, how many eggs do you have? You got 6 dozen eggs. How many? How many? 72. What'd you do? You multiply. How many atoms do you have if you've got 6 moles of atoms? You go, I can't do that. That's way too big. I can't do that. Okay? So you would take 6 times 6 is 36. Move the decimal over 1. So it would be what? 3.6 times 10 to the 24th. I got it. Okay? Don't get psyched out with such a big number. Okay? 1 mole, 1 dozen is equal to 12 eggs. 1 mole of atoms equal to that number of atoms. Okay, so now we get to this point of weighing. They got this thing called a molar mass. And a molar mass is the weight of Avogadro number of atoms. It's the weight of 1 mole of atoms. So the molar mass, when we take a look at molar mass, these are definitions you guys have. It's the number of grams of 1 mole of atoms. So how many atoms is that? How many atoms do we have? 6.02 to the 23rd atoms. Or 1 mole of atoms. What would you guys rather use? Would you rather use 1 mole of atoms? Or would you rather use 6.02 to the 23rd atoms? Yeah, moles of atoms. 1 mole. I got 1 mole of atoms. Oh, no, I got 6.02 times 10 to the 23rd. You say, well, they're the same thing. It really doesn't matter. I'd rather use 1 mole of atoms. So let's compare all these and see how they all work, okay, together. So we're going to, first of all, we know that 1 mole of atoms is equal to 6.02 times 10 to 2 times 10 to the 23rd atoms. Okay, so now where does weight come in? Well, that on the periodic table is 1 mole. Any of those atoms that we talk about. Okay, so that's equal to the molar mass. And the molar mass is the same as the atomic weight. So the molar mass and atomic weight is the same number. Okay, it's exactly the same number. So I'm going to put some statements up here. You're going to look on the periodic table and you're going to answer the question. You're going to fill in the blank. Okay, and then once you fill in a few of these blanks, you'll understand how these kind of work together, and we'll do a couple problems. Okay? So here we go. Fill in the blank. 1 mole of carbon atoms equal to how many grams? So where are you going to look? On here, right? You're going to find carbon, right? So how much are we talking about? 12.01 gram. That's a conversion. When you guys were in freshman or sophomore science, you got this big list and it gave you 1,000 grams equals a kilogram. 3 feet equal a yard. So on and so on and so on. Okay? 1 mole of carbons equal 12.01 carbons. Do you think I'm going to give you all of those on the sheet? I've already given them to you on the sheet. They're right here. They tell you what they are. Okay? So let's say that I have 24.305 grams of magnesium. How many moles of magnesium atoms do I have? What? Fill in the blank. 1. Okay, I know that 24.305 grams of magnesium is equal to 1 mole of magnesium. Okay, let me give you a little tougher one here. Let's have 6.022 times 10 to the 23rd atoms, not moles of atoms, but just atoms straight across, of copper. How many grams of copper do I have? 63.546, right? So, you guys do not have to be given the ratios because they're here. I'm not going to give those to you. One last one. Okay? One last one. Let's go ahead and do this one. What if I have 6.022 times 10 to the 23rd atoms of mercury? How many grams of mercury do I have? 200.6 to 200.59 grams. Okay? So now, these are our conversions. Let's just take one of them. Now, you're not going to have to do this every time that you have to do a conversion, but let's say that we have 100 grams of magnesium, and we want to know how many moles of magnesium that we have. How are we going to set that up? Any ideas? Do you know how to compare moles to grams of magnesium? I just did it for you up here, right? So if we would do that, it'd be 100 grams, and then we do our conversion. What unit goes down below? Grams of magnesium, right? Okay. Grams of magnesium, and then what goes up above? We're going to moles. What numbers go in there? What goes down here? Whatever's on the periodic table, 24.305. And then what goes up above? 1. I divided out and I got my answer. So that's basically a little over 4 moles that I have. I go 100 divided by 24.305, and I get 4.11 moles. I've counted atoms, but I left it in moles. Does that make sense? Okay, let me give you 2 more, and then we'll give you a chance to work through a few of these. Okay, so you know your conversions. 1 mole equals the atomic weight, which is a molar mass, which is equal to 6.02 to the 23rd. You know all your conversions. All right? So I want to know how many atoms total, not moles of atoms, but atoms in general. I want to know atoms of nickel. Okay, and I know how many grams I have. I've got 50 grams of nickel. So I want to know how many atoms, not moles of atoms, but atoms. So out in front I put 50 grams of nickel, and then I'll let you do the rest. And over here we want atoms of nickel. So fill in the slots. Are we going to use 1 mole in this example? No. It's not asking for moles, and you're not given moles. So we're not going to do moles. Are we going to use grams in this example? Where do we get the grams off of? Periodic table, right? So we look up nickel. Nickel is 58.693. 58.693. What goes up there? Atoms. So what number goes with atoms? 6.02. Not moles of atoms, but just atoms. 6.022 times 10 to the 23rd. And then I do my calculation. And I find it. Okay. All right. I'm going to go ahead and give you your assignment. I said I was going to do 2 more, but we'll see how well you do on these. Setting them up. The number, if you plug in this in your calculator correctly, some people have trouble with scientific notation if we haven't done it for a while. You should get an answer. It's 5.13 times 10 to the 24th. Atoms. Okay? So, what I'd like you to do, and I'm going to write it on here, page 85. Page 85. You're going to do, have you do 1 and 3 at the top. Okay, at the bottom, there's a couple other problems to look at. At the bottom, I want you to do 1 and 3. So 1 and 3 on both the top and bottom. And on page 86, I'm going to have you do problem number 3. Now, this is completion. You have to have it done. The appendix is in the back. So if you want to look up answers for those type of problems within each of those units, you look in the back and it has appendix. And the appendix is under atoms, the building blocks. Okay, and there's practice problems A, B, C, and D. So I think we're doing practice problems B, C, and D, I think. Okay, B, C, and D is what we're doing on those 2 pages. B, C, and D. B, C, D. Okay, show your work. Don't just show answers based upon the calculator and what it reads. Now come around if you guys got questions.